Okay, so today I'm going to talk about some work that we're very excited about. It's a little bit wild. We kind of started this project about a year ago. It's so wild we don't have slides. Okay, and so we started this project about a year ago. It's really not our area of expertise, but we just kind of had so excited about this that we really wanted to work on this. And so I'm going to tell you the story about it and the progress that we've made. Okay, so what the way this started is us realizing that we are really bad at knowing whether an animal is intelligent or not. We actually are really bad at knowing what is intelligence, right? And I think it's like fundamental for or AI in some ways, right? What does it mean to be smart? And my favorite example of this is the elephant, where a lot of cultures have known elephants are very smart. They actually have a lot of skills and they can do a lot of things. But every time a scientist tried to give an IQ test to an elephant, they always failed it. It was like every time you tried to quiz it, it just like couldn't do the task. It just was seemed to be really dumb. And so all these papers that came out about elephants kept on reporting these low numbers about their intelligence compared to dogs or other or monkeys or so on. But people who were very familiar with elephants, they kind of understood that they were actually quite smart. And the reason for this is that basically, whenever people would give an IQ test to a elephant, they would have to have the elephant use their trunk to do different things. Their trunk is like their hand, right? But it turns out that for e- elephants, their eyes are actually not great. They actually can't see very well, and their primary sense is smell. So all the IQ tests basically required them to plug their nose, right, in order to do things, and that's why they were not very smart, right? So they had them pick up sticks and so on like that. In the last, like, I don't know, 15, 20, 10 to 20 years, somewhere around there, there's been a lot of results coming out about elephants where if you redesign the IQ test around smell, right, they actually are extremely smart. Here's the elephant trying to get some food up in the tree there, and the elephant has figured out, without any type of training, has figured out, oh, I can push this tire over, so I can stand on that in order to get the food. Kind of even more remarkably, here the elephant, this video is too long to play in this short talk here, but it's trying to get the food, and what it figured out, it remembers, oh, there's a box in the back here that it can go grab, and then bring it back and push it over in order to grab the food. Um, Turns out that if you put an elephant inside of a maze trying to find things, they actually can navigate the maze via smell. Um, and so they actually know where to go. You can create some sort of complex maze for them to do. They even can determine whether something is explosive, right? Just from smell. So here it's been trained basically to lift up up its leg. Um, so the sense of smell in elephants actually is much stronger than dogs. They're actually one of the creatures that can smell the best. And so we kind of were realizing there's this whole world of intelligence here about smell. Um, and could we build AI systems basically that try to understand and interact, and robots that can interact in our world using smell as modality to sense? So this idea we got very excited about, and we created this data set. We're here in New York, and we realized New York's actually an amazing place to work on this, because everything smells so bad. Um, you know, uh, and so this was a project done with a very impressive team of students. My very close collaborator Andrew, who was in the room here. Where are you, Andrew? Uh, oh, he's over there. Yeah, and Andrew Owens and I have been working on this project. We're computer vision people by training, so this has kind of been a wild project for us to explore. But we just kind of got so interested in this, and so we built this contraption. We basically bought this electronic nose, and of course it doesn't have a battery. So the student had to walk around with a suitcase lugging a giant battery. It looked like a bomb. And basically we mounted a camera on this. We 3D printed this thing and put this camera there, and walked all around New York City, basically capturing what the smell was of different objects and what the corresponding picture was. Um, So we went all over the place. There's like inside, outside things. A student even went to the gym, and that has some usual smells, I'm sure. Um, but yeah, it's this diverse data set that we built. It's actually, to our knowledge, the largest one. I mean, I think by a lot of machine learning standards, this is not that large, of course, right? But this was like one of the larger ones. It's very hard to collect this data, right? You have to walk around, and you can't just go to the internet and download this, right? But it covers all these different types of of things. And so now the question is, how do you do machine learning on top of this, right? What is the right way to do machine learning on top of this? And it's actually, smells a hard modality to work with, right? Like if you look at sight, right? Sight, like in your eye, right? There's basically four different cell types that you see rods and cones, right? You see color and how dark things are, and that's all. Just biology has tiled that basically, right? So you can see a image. Hearing's even simpler, right? It's just one cell type that's tiled to hear different frequencies. Smell basically has, in humans is around, I think it's around 200 to 400 in humans, and elephants are all the way up to 2,000 different smell types. And so this is a combinatorial space, right? In vision, there's all these like invariances. You know that like, and Andrew over there is going to look exactly the same as Andrew over here. That's not true in smell, right? This is a combinatorial space, and there's lots of weird things that go on here as well. So this makes learning actually quite hard. So the way the nose works, this electronic nose. Oh, sorry that the sex is so small. Is that there's some smell source, right? That green blob there, and the device basically sucks in. It breathes, so to speak, right? It sucks in the air, and then there's these wires here inside the chamber here, where there's a charge going through it, and what you measure is the change in resistance. Right, so the molecules in the air are going to bind to these different wires, have different coating on them. Each one's resistance is going to change in a slightly different way depending which molecule rides on it, and so you get this time series. What this looks like on real data. So here's a apple, and inside this sensor that we have, there's 32 different dimensions. And so you can see kind of how this is going to change over time as you smell the apple. So what we did is basically we could collect this large data set here, and we just train a transformer to do contrastive learning between vision and smell, basically, to learn this and learn basically how to use this raw signal here. Right? This is kind of uninterpretable, right? How do you understand? If you can understand what's going on in that matrix, please tell me. We don't really know, right? But so this is like perfect for machine learning and deep learning in some ways, right? Is we have this raw sensory data. Can vision be used to label that, right? Okay, so we beat kind of it was kind of easy to get state of the art here, because a lot of the state of the art things were these handcrafted features. They tried to design doing min and maxes and normalization on these things. We just threw all that out and put a transformer on, and basically we did much better. I mean, the absolute numbers are still low, but much better than what the prior art was able to do. Didn't really matter if you do transformer or CNN as your backbone. But yeah, it has all these cool results. And it could basically this is all reckonings from smell alone. The pictures are basically there, just for you. It doesn't use the pictures and test, but it can recognize plants, right? It knows what materials there are. There's materials and objects in this data set. Knows that this is copper. It kind of guesses that this is probably inside as well, right? All these different types of things. The embedding space thinks that books and trees are very close together, which I think is really cool result. So yeah, there's this huge wild world of smell, and this is just the start for us, right? We really want to put this on a robot next, and have a robot find things via smell. This thing here is a nightmare. This is basically a mole that can smell extremely well. It smells under water by blowing air out and then sucking it back in, and that's how it's able to smell. But in terms of being able to do navigation, right? Can you find things via smell? Can you recognize the state of food? Is it bad, right? Um, and it also has lots of applications in health. This is a wild story. This is a woman, Joy Milton, I think is her name. She's a super smeller. The story is she started realizing certain people smelled weird. Um, and they soon realized that she could smell whether a person has Parkinson's or not. And they brought her in to test her. They showed her 12 different people, and I think she could basically, on these 12 people, she was 11 out of 12 correct at recognizing whether they had Parkinson's or not. But what's even more wild is then, like, a couple of years later, the person she got wrong developed Parkinson's. So this kind of led to a lot of discovery about Parkinson's. They could use this basically to figure out more understanding about Parkinson's. So all I mean to say is that if you could do this inside of a machine, right? I think there'd be tremendous uses in health. Okay, I'm probably out of time, but I'll stop there. Thank you very much.